back, dear students of class 12. So today we'll be discussing about proteins. So to understand protein, first we need to know what are amino acids. Okay? So amino acids are the basic building units of proteins. So this amino acid, whenever they are condensed together in large molecular polymeric form, then they give up what? They make it protein. Now you have to understand this amino acid, they contain both this amino group, that is NH2, as well as carboxylic group, that is COOH, in the same molecule. So let me represent it by general formula. So these amino acids are represented by this formula, NH2 CH, here R, and here you have COOH group. Now here you have a carboxylic group and here you have a amino group. So both the functional groups are present in the same molecule, and this carbon is alpha carbon. Now since this carbon is alpha carbon, these are all known as what? These all are known as alpha amino acids. Now based on different R group, that means whenever you substitute R with different groups, then you get different amino acids. So R, whenever R is equal to, now this R, whenever it is hydrogen, then that will give you glycine. Now this R, if you change it with CH3 group, that is methyl group, that will give you alanine. Okay, so the general formula will be same. Only the thing that changes is this R, and as you change R, you get different amino acids. Okay, so let's discuss in more detail about amino acids. Now in neutral solution, amino acids will be staying in a dipolar form. Now before discussing that, let's discuss about classification of amino acids. Now generally amino acids are classified into two groups, okay, based whether they are essential and non-essential. So amino acids are classified as essential amino acids if they cannot be synthesized within our body and it has to be supplied from outside source. Then they are known as what? Essential amino acids. And non-essential amino acids are those amino acids which our body can synthesize. Okay? So that was the classification of amino acids. Now let's discuss about more important term, that is dipolar nature of amino acids. So as I told you just now, this amino acid CHR COOH. Okay, this is the general formula of amino acids. Now in neutral solution, what will happen is, now they will in neutral solution, now whenever this amino acid is in solution, then they will no longer stay in this form, they will convert into some other form, and this is very important. Please listen to this carefully. You know nitrogen contains lone pair with it. Nitrogen contains lone pair. Now this nitrogen's lone pair will abstract this proton of COOH group. Please don't forget this. Now this will abstract this proton, and as a result, here you will be having H3, and now it becomes positive, and you have CHR, and here now it becomes COO minus. As this is abstracted, the bond here breaks over oxygen, and as a result you will be having a negative charge. Now here you can see that in solution form, amino acid has positive charge as well as negative charge. Therefore, it is known as dipolar nature of amino acids, and this structure is known as Zweitter ion. Okay, ZWITTER, Zweitter ion of amino acid, and this is very important. Okay, both Why it is known as dipolar? Because it has positive charge as well as negative charge in the same molecule of the amino acid. And this form exists in solution form, neutral solution. Now, let me tell you, this amino acid now will act as what? It shows amphoteric nature. Amphoteric means, now this form of amino acid will be reacting with both acids as well as bases. So now let's discuss more about its amphoteric nature. Amphoteric nature, okay? Now see, now whenever we have say in acidic solution, how does this deuterionic form react? You have NH2H. Deuterionic form means you have here 3 NH3 plus CH R. Here you have COO minus. Yes or no? This is deuterionic form. Now, whenever it is acidic solution means what is available? H plus ions are available. Now, this H plus ion will be taken by this COO minus. Please remember this. This will be taken by this COO minus. As a result, you have NH3 plus CH R. And here you have COOH. So in acidic solution, this is from acid. So in acidic solution, what will happen? This COO minus gets neutralized because of protonation, and as a result, this molecule now, deuterionic form, will be having only positive charge. That means it is a cation now. So it is existing as what? Cation. And you know, now if electricity is passed, means in the electrolytic process, what will happen? Cations will be going to cathode. Please remember. So this is a cation in acidic solution and will migrate to cathode in or doing electrolysis. Okay? So in acidic solution, what will happen? This deuterionic form of amino acid will be existing in cationic form, means they will be having positive charge, and as a result, what will happen? When electrolysis is carried out, then they will migrate towards cathode. Cations will go into the cathode. Now, similarly, in say basic solution, what will happen? Here we have NH3 plus CH R, and here you have COO minus. So basic solution means you will be having OH minus ions available in the solution. Now this OH minus ion, please remember, will abstract a proton from this NH3 part. So this NH3 part will provide one of the proton to this OH minus. As a result, now that will convert into water molecule. As a result, you will be having NH2 CH R COO minus, and here that has combined with OH and will be giving you water molecule. Now here you can see that in basic solution, what will happen? In basic solution, this amino acid is existing as negative ion. That is, it is anion. It is what? Anion. You have to remember this. This is very important. Now this anion, during electrolysis, you know, where will it migrate? It will migrate to anode. So it will be going to the anode during electrolysis. So the questions might be asked, like in acidic solution, where will this amino acid migrate? So you have to remember, in acidic solution it is positive, therefore cations will be going to the cathode. Similarly, in basic solution, it will be existing as negative ion, and negative ion is what? Anion, and anion during electrolysis will be migrating towards anode. Hope this is clear. Now, let's discuss about isoelectronic point. So, here we have seen that in acidic solution it is migrating towards one of the electron, and in basic solution it is migrating towards another respective electron. But there is a certain pH range of amino acids where it doesn't migrate to any of this, either anode or cathode, and this pH range is known as what? Isoelectric point of amino acids. And for neutral amino acid it is between 5.5 to between 5.5 to 6.3. So what is isoelectric point? So it is the pH range in which amino acids do not migrate to either of the electron. Okay, and that point is known as what? Isoelectric point. And the pH range of isoelectric point means the deuterionic form of amino acid will not migrate to any of the electron, and the pH range for neutral amino acid is 5.5 to 6.3. So you have to remember this value. Now let's discuss about peptides. What are peptides? So we discussed about amino acids. Okay, now these amino acids, whenever they condense together, so we are going to discuss about peptides. So let me take an example of amino acid CHR, C double bond O, OH. This is one of the amino acid. So let's take another amino acid, NH. This is NH2 itself, NH2 CHR dash, say C double bond O, OH. Okay. Now, whenever this amino acids, here I have taken one molecule of amino acid, here I have taken another molecule of amino acid. So whenever they condense, what will happen? A molecule of water will be removed from this particular two amino acids. Now here I have represented by R and R dash, means these are two different amino acids. It could be same, okay? It could be R. But to avoid confusion, I have represented this with R and here R dash. So a molecule of water will be removed, and this molecule of amino acid will be condensed with this molecule. That means a bond will be formed between this carbon and nitrogen now. So let me write this product: H2N CHR C double bond O, then NH CHR dash C double bond O OH. So here the two molecules of amino acids, they have condensed together. Now here this is the bond. This is the bond by which amino acids have condensed together. Therefore this is known as what? Peptide linkage. Okay, and since these two molecules, they have condensed together, therefore it is known as what? Dipeptide. This is known as what? Dipeptide, because two molecules, they have condensed. Similarly, now if you treat this dipeptide with, say, another molecule of amino acid. So let's take another molecule of amino acid, that is, say, NH2 CH. Now I'm taking here double dash. R double dash is the third molecule. So here you will be having C double bond O OH. Okay, so whenever these two react again, what will happen? Suppose these two are reacting, then what will happen? Here, again, a molecule of water will be removed. I am writing this as this side so that I can show you how this water molecule is removed. So this is NH2 itself. So this water molecule will be removed. Now again, a bond will be formed between this carbon and this nitrogen. So let me write this structure then. So I am going to write this structure up here, so that I can write the whole chain in a straight line. Okay, so hope this is already known to you. Now let me write when this dipeptide will combine with the third molecule. Okay, so I'm writing the product here. So you will be getting NH2 CH R double S C double bond O. Now this C double bond O is connected with this nitrogen. NH CH R. Here you have C double bond O. NH. Okay, NH C double bond O. NH CH R S C double bond O. OH. Now here we have this peptide linkage, and here we have the peptide linkage. So here we can see that three molecules of amino acids, they have condensed together to give now what is the name of this particular compound? It would be tripeptide. Tri means three molecules have condensed together. Now this way they can keep on condensing, and they can come together and can form a very large molecular chains, and we can control it according to our will. Okay, and whenever you get such a large chain, then that is known as polypeptide. Okay, polypeptide. Please remember polypeptide. Whenever these many amino acids they condense together, then that is known as polypeptide. Now here this is very important. Now please listen to this carefully. Okay. Now this polypeptide, whenever their molecular mass is more than 10,000 units, then they will give rise to proteins. Please remember, polypeptides with molecular mass greater than 10,000 units, then that will result in the formation of proteins. So we have begun our discussion with amino acids for the discussion of protein. Now I hope this is clear. Amino acids, they keep on building dipeptide, tripeptide, they keep on building, and once they form a very large chain, then that is known as polypeptide. Now this polypeptide, when their molecular mass crosses or is more than say 10,000 units, then that is known as proteins. Okay, hope this is clear. Now let's discuss about denaturation of protein. Now, denaturation means, okay, so here we have denaturation of proteins. Now see, the process which leads to a change in physical and biological properties of proteins without affecting its chemical composition, then that is known as what? That is known as denaturation of protein. So what you are doing? You are leading to a change in physical and biological properties of protein without changing its chemical composition. And that is known as denaturation of protein. Now denaturation can be brought about by heating it, by treating it with alcohol, by treating proteins with concentrated acids, and also by the help of radiations. So that is all about denaturation of protein. And now in your syllabus you also have classification of proteins. Okay, on the basis of structure, that is primary structure, secondary structure, tertiary structure, and we have quaternary structure. Okay, now I urge you to go through the structures of these proteins, okay, from your book, and if you have any doubt regarding the structure, you are always welcome to text me. Since you all have my WhatsApp number, you can ask me all your queries over there. So this is the end of today's class. We'll be seeing you in the next class. Take care till then. Thank you.